Welcome back, students. This is section 5.1, and I'm looking at M4, 4 midpoint rectangles. This means using the midpoint on each subinterval. Same function, y equal x squared here. And now we still have the same subintervals, 0 to 0.25, 0.25 to 0.5, 0.5 to 0.75, 0.75 to 1. So those are all of these 4 subintervals with n equals 4. Aren't you glad we don't have to do n equal 10? We could. Don't want to. To find the midpoint, we're looking for the middle point. So to find a midpoint, you just add 0 plus 0.25, divide by 2. You get 0.125. You add those, divide by 2, add the 2 endpoints, and you get 0.375, 0.625, and 0.875. And I put those on here. These are your midpoints. So these were techniques developed trying to find, and what we do then, I probably shouldn't have done that. Oh well, there's your midpoint. And you now draw a rectangle that goes through that midpoint like that. So it's partially under the curve and partially over the curve. So let me try that again. This is going to be, I'll do a dotted line here. That'll be the height of the rectangle, but you draw the rectangle using the midpoint. Now you can see why they might want to have developed this technique, because it's probably a better approximation. You got partially over, partially under. Those aren't equal, but at least we're getting a good estimate. Let's try this one. That's supposed to be your height. Are you guys drawing along with me? So that's the midpoint of that one. And then this one, there we go. Those are your 4 rectangles using the midpoint on the interval. Now notice the midpoint is the height, but you go to the left and to the right to do the 2 endpoints. Now the M4 is going to be, they're all 0.25 width, as all the other rectangles we've done. So I put 0.25 out here, and then I put a parenthesis and just took the midpoint here, the 0.25. I know that that's y equal x squared, so it's going to be 0.125 squared plus 0.375 squared plus point, and so on. So I took each of those midpoints and squared them, put them in the function, and each one had a 0.25, so I just factored it out in front, and this gives 0.328125. Well, not only, if we had more time, trapezoidal rule was used. So in this case, you would go the 4 intervals or subintervals, and instead of rectangles, you use a trapezoid. So you take this one, and this one, and this one, and this one. And these are kind of shaped like this, where you have a flat side. So you would use these trapezoids and add 4 trapezoids. That's called trapezoidal rule. We're not going to do that, but if you want to, you could do that for fun. Simpson's rule is another one. This one's always kind of cumbersome. What is done here is you divide these into you got your subinterval here, and you do a parabola in here, and you have like 3 points, the end points, and then this one, and make a parabola. That one's a little more in depth, takes some time, but they worked very hard to try to find these. They're just trying to find this area. Okay. And we'll see what the fuss is about eventually. All right, I'll come back for number 2.